Hello, everyone. This is yours truly, Lady Emmanuel, coming to you with the graphing and analyzing quadratic function, lesson 29-2. Let's go ahead and read this information, do a little annotation. So, the learning targets are graph a quadratic function, interpret key features of the graph of a quadratic function. Okay, it's just basic characteristic in analyzing. We'll just go ahead and do that. So here's strategies. You can read that. That's on every lesson. Using a graphing calculator to graph A of L from item 9 in lesson 29-1. So we are connecting it back to the lesson. I didn't do all the assignment we discussed it in class. I made previous videos on modeling with quadratic function. So we're going to connect this item, and you probably say it says item 9, not item 2. You're correct. I went to item 2 because when I looked at item 9 does connect to the table. This table helped us to derive this function, which is A of L equals 160L minus L squared. Okay. However, we need to write that in standard form, which would give us, let me write this formula down, this function. So we have A of L equals negative L squared plus 160L. Okay? That's the function that we got from item 9 from the previous lesson. So here, it told us to sketch the graph on the grid below. They want us to use a graphing calculator. Now, if you make the connection, keep in mind that this function came from this table, meaning you already got that graph. Okay? Think about it. Look at this graph on page 424 in your packet. Then come to page 427. Look at the graph. You have the length of the rectangle, which is here. You have the area of the rectangle from previous lesson. Here's the area of the rectangle. Okay, it's the same thing. Okay, so we just gonna so what I'm gonna do is just take this, instead of using a calculator right now, I'm just going to use the information that we already have. So here, for when the length is 20, the area was 2080. So I'm saying 20. Go here, graph that. Then when it was 40. It was 4,800. Okay, and here I probably said 2,080, but it's 2,800. 60, it's gonna be 6,000. Okay, 80, it's gonna be 6,400. For 100, 6,000. 120, 4,800. It's 4,800, so it's here. So that means here I said 4,800, but you can see that's 3,800, so make the correction. And you'd be like, oh, you messed up. H-U-M-A-N, nothing wrong with that. So that's where you got erasers. So now we have 140, it'll be 2,800. Okay. And for 150, it'll be 1,500, so that's about here. But then if you come on down at 160, it'll be 0. Okay, and of course at 0, it'll be 0. So you just sketch, you plot those points, and you sketch it. And yes, I'm not perfect, so I'm sketching it. Okay, here we go. I have my graph. So I've done what they asked me to do. Here it explains that the graph of the quadratic function is a curve called parabola. So this curve, it's not a line. You see it has a curve, so it's a parabola. And it explains to you what a parabola is. It said that point is called the vertex of the parabola. It's talking about here, wherever it's the maximum or minimum. In this case, this is your maximum. It's the highest point. So this is my maximum. Okay. And if you notice, with our maximum, you notice that here it's like a reflection. And you guys know this from class where it's reflected over. You see here you got 2,800. Here's 2,800. Here is 4,800. Here's 4,800. 6,000, 6,000. Excuse me. So to me, this is the line of symmetry, which is called the axis of symmetry. Okay. So here, I'm going to, you probably say, they didn't say that. Well, I'm writing this anyway. That's your axis of symmetry. Okay. Your axis of symmetry there. But let me continue to read. But they got me. I sort of got this read. The maximum, which is, in this case, your vertex. It's that point is called the vertex of the parabola. We have that. The y value of the vertex is the maximum or the minimum. So that y value here is 6,400. In this case, it is our maximum. Okay? And you could put for maximum, it's the highest point. Okay? Minimum, the lowest point. It's identify the vertex of the graph of A of L in item 1, which we already done that. So this is the vertex, this is the maximum. Does the vertex represent a maximum or minimum of the function? The vertex represent maximum of the function. Okay. What is the maximum? The maximum is 6,400. There you go. It's to examine the graph of A of L for what values of the length is the area increasing. Now, what I'm going to do, I'm going to stop. I'm not going to continue with 3. I'm going to make a second part for that. I really want you to concentrate on the different parts, the maximum. What is the y value of the maximum? What is the length when it has a maximum? So that's something for you to really think about and make sure you understand the maximum and the minimum for that. Guys, I appreciate you. It's been good. It's been real. I'm making part 2 for you. Bye.